Hey everybody, my name is Jacob Sosine, and today I get to tell you about a really cool project I've been a part of for the past couple months, looking to apply natural language processing techniques to peer-reviewed behavior analytic journal articles. We have a lot to cover, so we're going to dive right in. One thing I'd like you to leave this talk with is more of an understanding of what natural language processing is, or NLP for short, our data pipeline and how we are able to secure and move data through it to the analysis phase, and how NLP can be used by behavior analysts moving forward. NLP has historically been the intersection between artificial intelligence and linguistics. It's looked to apply rules and structure to data and really been in line with linguistic theories of verbal behavior, and has used statistical methods to understand language. But more recently, with advances in AI and machine learning, NLP has moved away from those statistical models and more towards understanding the meaning or the function of what a speaker is trying to say. And these techniques are more related to the analysis of verbal behavior than linguistics. NLP allows behavior analysts to study verbal behavior at a scale that's previously been unrealized. Every day, there's 2.5 quintillion bytes of data that are uploaded to the internet. There are 682 million tweets and 4.3 billion Facebook messages that are sent. That's a lot of textual behavior that we could start to look at by speakers around the world. NLP also offers the ability to look at individual level behavior at the group level, or thousands of speakers at one time. It has been used to identify indicators of child abuse from pediatric medical records, has been used to detect humor in sentences, or classify hate speech in platforms like Twitter. It has also been used to summarize text and answer questions like Watson on Jeopardy a lot better than I potentially could. So now that we understand a little bit more about what natural language processing is, we're going to talk about our data pipeline. So in our data pipeline, we wanted to gather as many articles as we could. And then we had to extract those articles and pre-process them. And we explored the data and did something called topic modeling, which we'll cover in a little bit. So in order to gather as many articles as possible, we automated the retrieval of those articles. We leveraged Python, a programming language, and Selenium, an open source package, to simulate web browsing and gather open source access articles automatically. We were able to collect journal articles across the Journal of the Experimental Analysis of Behavior, Perspectives on Behavior Science, Journal of Applied Behavior Analysis, the Analysis of Verbal Behavior, and Behavior Analysis in Practice. In total, we gathered 9,763 journal articles for analysis. And we thought it'd be fun to include a control journal, so we gathered about 644 journal articles from health service research to look at the differences in our verbal communities. Once we gathered those documents, we had them in PDF form, but we needed to take it a step further to be able to analyze them. So we had to extract them using Python again and an open source package called OpenCV and PyTestRact. This allowed us to identify each individual word in those documents and extract them to be in text format. Once we did this, we were able to pre-process those data, which removes noise from our data set and allows a computer to interpret our inputs. The first step of this was to identify and remove all the in-text citations. Now, the in-text citations could be a really unique and interesting analysis in the future, but for our purposes, we needed to remove them. We then lowercased all the text, and we removed punctuation and symbols from the text. Once we did this, we removed all the stop words, which really don't add much to what the speaker is trying to say, but help the computer to process that information. Following that, we tokenize each word, which is applying a unique number to each unique word in our data set. And we did a process of normalization called lemmatization. With our data pre-processing techniques, we were able to explore our data set in novel and unique ways. We were able to look at things like word count per article across journals and do the same thing across years.
we're able to pull out pairs of words and see patterns emerge on how these communities are talking about things, as well as sets of 3 words, and see how those relative frequencies stacked up. We're able to look at the highest frequency words in the Journal of Applied Behavior Analysis compared to the Journal of the Experimental Analysis of Behavior. And in that, we were able to identify exactly how often these words were being used within those verbal communities. We took it a step further and looked at all of our journal articles and compared them to our control article. And as we can see here, we use some of those articles that are in the control article, but our highest frequency words are not used at all in that control. We're not limited by just graphing the highest frequency words though. We can pull in all words in our corpus and start to look at how we are common across verbal communities. So now that we've done some very basic exploratory data analysis, we're going to talk a little bit about topic modeling. Topic modeling is a very cool way to explore data, and it's an unsupervised machine learning technique. It's aimed at looking for hidden semantic structure within text. So for example, if you have a topic that's related to the matching law, you would expect to see choice, rate of reinforcement, and concurrent schedules of reinforcement. And topic modeling, in essence, is telling the computer to look for the topics in the specific text and allowing it to identify them on its own. So topic modeling visualizations include a topic bubble, where each bubble represents one single topic. And the further away a bubble is, the more different the topic is. And they also include a horizontal stacked bar chart. The blue bars are the overall frequency of each word in our data set, and the red bars are the number of times a given term is generated in the topic. We can also adjust the ranked terms according to their term relevance. So remember, in our topic model, we have topic bubbles. These are those topic bubbles here. Each of these topic bubbles, the distance between one and the other and each other is how closely related these topics are. So as we can see here, these topics are very closely related. As we end this one compared to this one, not so related. And each of these blue bars describes the frequency of each word in our data set. We can start to see that treatment occurs in many different spots, or that problem occurs most likely here in topic 4. And in the red bars, when we start to click on these topics, we can see the number of times a given term is generated in that topic. Maybe this topic is about functional analysis or treatment of problem behavior. We see attention and reinforcement, demand, which may indicate that this is exactly what that's talking about. What about topic 1? What is this one? We see that this is about training, and there's participants and sessions and stimuli, skills, interesting stuff. We can even adjust the relevance metric to look at differences. So these are here we see children pops up a lot in this topic. Really cool. What about over here? We can see that these topics are all closely related. Maybe that there's some common feature that this model is picking up on. Or here we can see that this is also has the word training or behavior or relations. I wonder what that topic is. Oh, we see down here it's equivalence. So we can begin to take things a step further and look at the prevalence of each topic across years. For Java, maybe it's looking at the decrease in the prevalence of one of these topics. Or for JAB, it's looking at the decrease in one of these. Or the emergence of a different topic. So now we've looked at what natural language processing is. We've discussed our data pipeline, but this analysis was not without limitations. We're only able to review published journal articles. Those are largely a result of complex behavior chains, and we're unable to bring in antecedents and consequences into our analysis. But even with that, there's value at looking at what a speaker is saying. And we can start to look at these verbal communities and see these curious phrases and see how people are engaging in these behaviors. So where does NLP land moving forward? Well, one easy next step would be to bring in metadata that starts to provide the context in which the speaker is behaving. Things like location or what the speaker is doing, or types of tags that can be added or are added to certain data sets that are publicly available. We can also start to see the direct consequences of these behaviors, such as likes, subscribes, retweets, comments. And moving forward, we can also start to envision verbal behavior and tag it as manned or attacked and an autoclitic. And that will allow us to look at how these things modify the likelihood of any given consequence. So even in its simplest applications, NLP can increase our understanding of behavior. We've demonstrated a few of those very simple things today. And leveraging this technology can allow researchers to ask different research questions and start to get at different things that weren't previously an option. And NLP right now is more accessible than it has ever been for any behavior analyst to learn and start to use in their research. So thank you for your time today. I appreciate you spending your time with me, and it's been really fun to be able to present this topic. If you want to connect, reach out, send me an email. I would love to collaborate on different projects. Thank you.